do it from your end. All right, perfect. All right, yes, hello. Thank you for being here, everybody. I see some familiar faces and some other people who I don't know, so that's very cool. Vincent already said basically everything that's on this slide. So Mateo is Machine Translation Evaluation Online. It's a project that was funded by the EMT, or the European Association for Machine Translation. And the most significant grant was from Clarin. It was conceptualized and developed at Ghent University. These days I'm at KU Leuven. And it's hosted at the Dutch Language Institute. So we'll be using that link later on. And everything is open source, and it's also a GPL license. So if you're from the industry or you want to do something with it, you're free to do that as well. Okay, but what is it really? So it's a platform to automatically evaluate machine translations, or MT. And we do this by comparing the output of a machine translation, so machine translations, with reference translations. And we do this with automatic different metrics. And we have a couple that are established, that are frequently used in research, like BLEU and character Aventure, but also state-of-the-art metrics. So these are BirdScore, Comet, and BLERT. The established ones are faster, but the state-of-the-art, they're slower, but they correlate better with human judgments of quality. So basically what we want to do is, if I give machine translations and reference translations, Mateo has to tell me, okay, how good were these machine translation predictions? And you may be wondering, well, I'm not quite technical, so maybe this tool is not for me, or you're very technical, and maybe this tool is not for me. But the whole point when we were creating this tool was to have a tool that serves a broad spectrum of users. So both people who might be new to this, students, for instance, who want to get into machine translation evaluation, as well as experts like machine translation system builders or people from industry, that it should be easy to use to begin with, but there should be enough options for expert users there as well. Okay, so maybe I've convinced you now that it can be useful for you. So how can you use it then? As we said before, it's hosted on the Dutch Language Institute website, but it's also on Hugging Face, and we'll come back to that later on. And you can host it yourself on your own server or your own laptop if you want to, with Docker or Python. If you want more information, again, most information is on the website, but the code is there as well. There's some articles and interview that you can have a look at for a bit more background info. And then if you want to get in touch, a bit informal, you can get in touch on Twitter or LinkedIn. And if you want, you can also send me an email. As I said before, the project was developed at Ghent University, but now I'm at KU Leuven. So if there are no questions up to this point, we can immediately go to the demo itself, or the tool itself. The Zoom bar is in the way, so I'm going to try and move it somewhere else. Okay.
I see raised hands.
Oh, sorry, I wasn't mentioning. Or yes, you did. Go ahead.
Hi, Bram.
Hello.
You mentioned that the tool is useful to evaluate how good an MT system performs.
Mm-hmm.
Are there also other use cases you can imagine?
Not sure. So the main point is indeed evaluating MT systems. So you give the output of an MT system and you compare that to a reference translation, and then you know how good the MT was. But of course, even though that's the end goal underlying, as we'll see, there's also a purpose for educational settings, right? So that we can explain to students what is machine translation evaluation, which metrics exist, how do they work, and how can I apply them? Not sure
Maybe
if that answers your question.
I can add something. I think you could also use, well, BLEU and so on are also used in other tasks where you just want to compare output strings with reference strings. So it might be useful in those cases, like text simplification, summarization. Maybe not all metrics, but at least some of them are also used in those settings.
Yes.
Okay, thank you.
Okay, so no more questions, I think. Sophie, I don't know if you caught the URL, so I'll put it in chat anyway, just for you, for ease of access. So this is the main page. I'll go over all the pages that we have here in the sidebar.
Bram, we still see your PowerPoint.
Oh. Yeah, I'll stop sharing and reshare them.
All right.
All right. So on the sidebar, we have a couple of pages with different kinds of information. On the main page, just a little bit of background citation information. So if you use the tool for research, please do cite it. It's useful for us to know how used or useful the tool is. Some information about funding, which we already discussed, and then how you can host the tool yourself. So maybe I should go through this briefly, just for you to know that you can indeed use it on the website here itself, which is hosted on a powerful server. But if there were to be issues, there are alternatives as well. So if we click on this link, we end up on the Hugging Face Spaces, as it's called. So Hugging Face Spaces is basically a platform where you can host machine learning demos for free. And so there's a copy of the website running here as well. But what's useful about this is if you go on the top right here, there's this button, duplicate the space. And what this does is it makes a copy again of this website to your own profile. And so it makes sure that no one else is using that instance. So if you have a lot of data to process and you want to use a lot of computational resources, that's a good way to go, because then all the computational resources are dedicated to what you are doing. So that's an easy way for you to do that, even if you're not quite technical, right? It's just two clicks of a button. Alternatively, also quite easy, I think, if you're a little bit familiar with Python, there are instructions on GitHub on how to install it on your own laptop or server. And then if you're a bit more tech savvy, then with Docker, you can do it as well. You might argue that Docker is easier than Python, but I don't know. You can have a look at the instructions there. And then, as I said, some contact information, or if you find issues or bugs, please report them here as well on GitHub. There's a link here as well, so we can fix it as soon as possible. Then I'll move to the background here. So this is what I referred to earlier. So this is some more background about metrics that we support, which I think is useful if you're not too familiar with it. So also if you use this in classes, it's useful for students to just quickly go over it. And so we have baseline metrics, as I mentioned. So they're often fast, but their correlation with human judgments is a bit lower. And we have neural metrics as well, which are quite slow, but they correlate better. And then for each of these metrics, we have a link to their paper, to the implementation, so the source code. And we also specify which version of that code we use. And then for some of these models, also the languages that are supported. So you can have a look whether a metric works or is suitable for your language. Yeah, so all 6 of them are here. Then, before going to the evaluation part, we also have a translation component. And this is a bit secondary, so that's not the main point of MATEO. The main point is evaluation, but we also have this component to make translations. And the idea behind this was that we often find in classes that we want to explain how these metrics work, but then you need machine translations or translations. And it's easy to just use Google Translate and DeepL and all these commercial systems. But then we wanted to have a comparison with open source systems. So the model behind this is Facebook or Meta AI's no language left behind model. So it's an open source translation model that supports 200 languages. And we are using the small variant here. And this allows you to quickly create translations from or to 200 languages. So the main idea behind this is for you to create baseline translations that you then can use for the evaluation part. And so if you're a power user or an industry, this is probably not something you will need or use. But for us, it was more from an educational perspective. And that brings us to evaluation. And so this is the core part of MATEO. So the first things first, we can select from the 6 metrics which one we want to use. So it's as easy as clicking on a checkbox. So I want to use bird score, let's say, also Comet, which is common, and let's use all the baselines. I'm not going to use blurred because it's a little bit slower. And so that's as simple as it gets, I think, just selecting whether or not you want to use a metric. The important thing here is that you can get access to advanced parameters for all of your metrics. So for TER, for instance, it lowercases your data by default. We can disable that if you want to. We also get an explanation what each of the options do. So even if you're more of a beginner, you can still get some information if you want to be adventurous and go look at what options are available. And for the neural metrics, we also have these options, but because we are running on one server, of course, we do not have all options. So normally, for instance, I think Comet is a better example. You can have massive models which are useful and powerful, but of course, if we have this in our one interface here on the server and a couple of people start using it, then it will get overloaded quite quickly. So we have a kind of a demo mode that is enabled at this stage. But of course, if you're running on your own device or your own server, then you have a lot of control over this and you can have any option that you want to. So here I have selected the 3 baselines as well as bird score and Comet. And now we can go to data. And so as we said before, it's a reference-based evaluation. So we have to select a reference file. I will select, I have prepared some data from the WMT shared task, and this is English to German, German to English, English to German. And you'll see that because we selected Comet, we also have to provide the source files. So Comet is kind of a special metric in the sense that it evaluates a translation by comparing it with both the source text and the reference. So we also upload the source. And then we'll be comparing 3 different systems. And as you see, as soon as we add more than one system, the first one will be marked as the baseline system that the other systems will be compared against that system. As a baseline, I'll be using the translations from that open source model that I mentioned before, so the Meta AI no language left behind. As a second model, we'll use Opus, so that's another open source language specific model. And then finally, you may have guessed it, we'll be looking at GPT 3.5 to see how it compares against open source systems. And with that, we're basically already done. So we have selected our metrics here at the top. We have selected the options that we want to. Then we have uploaded our data, and then we can evaluate. And this might have seem like it was super fast because these were 400 sentences. But there is a caching mechanism behind this website, which means that if a sentence was already processed before, then the website will remember this for, I think, 24 hours. So recomputation is quite quick. But if you do this yourself with your own data, it will be a bit slower, especially the neural metrics, right? And because I did this morning to test, the system remembers, and that's why it's so fast this time around. So for 400 sentences, we get corpus level scores, and we see we get output for all of the metrics that we selected. So bird score, bleu, character F, comet, and ter. And we see that for the baseline system, so the Facebook model or the Meta AI model, it's a little bit worse than the Opus model, which in turn is a little bit worse than GPT 3.5. And this is true for all metrics. For TER, the lower score indicates a better system. It indicates that you needed fewer edits to achieve the reference translation. But in any case, we see that the metrics in this case, all the metrics agree in this case. Oh no, except for comet apparently here. I hadn't noticed this. If you can zoom in a little bit if you want to. So we see a small difference here. Then if you double click, you go back to the full view. So this graph is for easy visualization. You can also download it here at the top, download it as PNG. You can look at it in full screen if you want to, and zoom in as I just showed. And then there's this other kind of plot, which personally I don't find very useful, but it's a radar plot where you see for each metric how each model fares. And so you see that in generally speaking, the GPT 3.5 model is best in all cases, and also for TER, but in TER, the lower score is the better score, of course. But I find this graph most intuitive. So that's the visualization of the corpus level scores, but then mostly if you want to write something down about this or write a report or a paper, then you'll probably want this in another kind of format as well. And so we have a table here with the results, and something that's probably more for expert users is that you also get confidence intervals, and you also get significance levels or p-values compared to the baseline. And so if you look into this in a little bit more detail, we see that indeed the Opus model, the score is a little bit higher than the baseline, but the difference is not significant. So Opus and NLB are not significant, except for one metric. So for character F, this difference is a little bit, well, is significant. But then GPT 3.5 is significantly outperforms the baseline by a lot in all cases. Just as a side note, this illustrates why I believe when you report on machine translation quality, you should include more than one metric, because your data there might be properties in your data that favor some metrics over others, and the results might not be consistent across your metrics. And so if you report this, it might be a good idea to report multiple outputs. So that's the table, and you can download this table as an Excel file or a tab separated file with or without your confidence intervals. And perhaps if you want to publish about this, you can also copy paste with this button here quite easily the results to LaTeX. And then something that we've seen in the last few years more and more is signatures. And so again, this is more the expert for an expert user or a researcher. As we saw before, you can change a lot of parameters for these metrics, but then if a paper does not report which settings they used, it might be hard to reproduce what they did or the results that they got. And so there's, since Sacre Bleu, the underlying framework that we use for Bleu and character F and ter, they came up with this thing that they call signature. So depending on the settings that you used, for instance, which tokenizer did you use, which n-gram size did you use, you get a nice shorthand description of exactly the settings that were used in the paper, and then other people can reproduce that based on that. This has been, I've adapted this so that it also works for bird score and comet. And here, just to be safe, we also add the version of MATEO that this was calculated in. Okay, so that was the corpus level evaluation. So we have seen visualization, we have seen the table, LaTeX, and signatures. But for some metrics, it makes sense to also go look at the sentence level scores. And so, for instance, this is often the case for neural metrics, where the corpus level evaluation is just a mean across all the sentence scores. And so here we can look at results in a fine-grained manner. And I'm gonna, for BERT score, the scores are quite close to each other, but I'll show you Comet in full screen. And so what you see here on the x-axis, we see every sample in your data set. So every vertical line is one sentence, and then every color is a different system. And so you can quite easily look at this and go, oh, so here this red bubble, or here this light blue bubble is a lot lower than the other systems. And we see, if we look at the column in the right, the legend, we see that the light blue is the Meta model, the Facebook model. And my German is not great, but you might then get an intuition of, oh, okay, this makes sense. And it's true that the Facebook model is a lot worse than the other translations, or it's not true and the metric is not doing its job well. So I think this is a useful visualization if you quickly want to do some more fine-grained analyses through the interface. So for the interface, it's easy to just go through this quite quickly. But if you want to do it in more detail, we give you these results as well as a table. So here again, you can look at the reference translations, the source text that came with that sentence, then the output of the Facebook model and the score that was given for that model. The same for Opus and the Opus score, and then GPT 3.5 and the score. And as before, you can download this file, this table, as an Excel file where each metric has its own sheet. Okay, I think I touched upon everything of this page quite quickly, and this was added more towards the end. It's a visualization of edit distance. I'll give a quick example. This is, again, mostly for educational reasons or just to look deeper in specific examples of translations. And so you can see the difference between translation where it is highlighted, what the similarities are and what the differences are when something is substituted, by what it is substituted, on both a character level and on a token level. So again, this is not the core of MATEO, but it's just a nice extra utility to have. But the main part is, of course, evaluate itself. And with that, I think I'm already done. So I don't know if there are any questions or concerns. So feel free to raise your hand. Yes, you did. Go ahead.
Yes, me again. You said for some of the scores, the source file is required. How
Yes.
about the reference file? Is it required for all the scores or only for some?
Yeah, that's a good question. So we, for all these metrics, we need references. So it's reference-based evaluation. That being said, so as you may know, or maybe I should have mentioned, so the project has finished, but we have submitted a thesis project for a thesis student to work on extending the framework so that referenceless evaluation also becomes possible. And so there are some metrics that work without providing the references, and these correlate worse with human judgments, of course, because there's nothing to refer to reference. But such metrics exist, and we would like to add them, but I don't really have the time myself to do it. But that's why we have, hopefully, a student who will work on this in the future. And if not, maybe I should mention that as well. So since everything is open source, this means that on GitHub, if you have a great idea and you're tech savvy yourself, I'm very open to accepting pull requests. So if you make an edit or something that you use and that you think is very useful, just let me know and we can see if we can integrate it. And then with the right attributions, of course, we give you full credit for the changes that you make, then we can integrate it. Because I think it would be useful to have a tool that has a lot of information in it and one canonical tool that more people use rather than everybody doing their own thing and having their own separate branch and doing things separately. So please do get in touch when you make changes that you think are useful for everyone. Any other questions or concerns? I have heard at a conference where we presented this that some people were asking questions about, okay, what about my data? If I upload my data, does that mean you store the data? The question is no. So for the duration of calculating the metric, your data is stored in memory, so it's not saved on disk or anything. It's not stored. And that has advantages and disadvantages, but the advantage is, of course, that we do not store any of your data. And so for privacy concerns, it should not be an issue. Katrien, yeah, go ahead.
Is there a maximum to the size of the files you can upload?
Yes.
And
So
how
have
you determined that?
The size is set to 1 megabyte, but if you see, so I uploaded a file of 400 sentences, and that's only 50 kilobytes. So it's for the demo purposes, I think it's quite large. And then when you do it on your own, so when you host yourself on your own device, I think the framework allows up to 250 megabytes, so very large files. How have I determined this? A bit trying things out and seeing what was feasible and what was not feasible. Yeah, that's about it. I guess you can fine tune this a little bit more as soon as we would have usage statistics, but I'm not recording any telemetric data or usage data. So I will never know, I guess, but it's a good question. I don't know what the optimal size would be.
Thank you.
Well, I think there are rarely bigger test sets than a few thousand sentences, I think it will be large enough normally in normal circumstances, and yeah, otherwise people have to install their own instance. That's fully agree with it. So if there's no further questions, then
Yeah, I think Jesse has another question. Sorry,
okay.
but he's not.
Yeah. Okay, so I'm not very familiar with all these scores. Can you give me references where some correlations of user evaluations with all these scores are given so that you get a feel for them?
Yes, definitely. So if you go to the background page, then I refer to all the papers, and all these papers, they indeed, the criticism is always, well, okay, you can present a new metric, but how well does it correlate? And so all of these papers describe how well their new invention, their new metric, correlates with human evaluation. And you'll see that for the most part, even though everybody still uses it, Bleu does not correlate well. But it's so grounded in research that it's still often used. From the baselines, I would suggest to use character F, and then for the neural ones, I haven't checked the latest research, but it will be between Blurt or Comet. Which one's the better one? You see Comet more, but I think that's because Blurt is a bit more difficult to run. It's computationally a bit tougher, so it's a larger model. But that would be my suggestion. So definitely check out the paper if you want to know more.
Okay, thank you.
Okay, then thank you, Bram, for the explanation. I'll ask my questions later.
I'm scared already. Yeah.
I stop the recording now, and thank you all for attending, and I hope you all can make good use of the tool.
Yeah.
Thank you.
I hope so.
Thank
Simone.
you for the
Thank
nice
you, everyone.
presentation.
Thank you.